you need to me to stop or something or repeat something, let me know, otherwise I'll proceed. Okay, I have 3 minutes. अच्छा but नहीं होगा, ठीक है, चलिए, इट्स ओके. अच्छा, so we have already discussed and entered into the projectile motion. Now I will go ahead to the discussion of acceleration. Is something which you already know. There is no point of discussing instantaneous acceleration, all those things we have already know. So I will go ahead to the discussion of, huh, when it comes to acceleration. Now let me just discuss something about acceleration, because so far we have discussed about speed, velocity, distance, displacement. Now I'm bringing to the concept of acceleration. Concept of average acceleration and instantaneous acceleration we have already discussed. Now what we are discussing is how your acceleration will be affecting the trajectory. So let's say your particle is moving along, let's say your particle is moving along this direction. Let's say your acceleration is towards downwards. We know that if your acceleration is zero or your acceleration is parallel to the direction of velocity, the trajectory is always straight line, because that will be following a straight line, I mean parallel or anti-parallel. But if your acceleration is making an angle theta or any angle, then it will be deflecting the particle from its own trajectory, and that is where you will be having parabola. So now any kind of situation where your v is making an angle, where v is making some angle with the acceleration, what will you do? Let's say hypothetically this is your v, let's say this is your acceleration, and let's say this is theta. So what is this component? A cos theta. And what is the perpendicular component to v? A sin theta. So the parallel component is cos theta will be helping the particle to accelerate. I mean, it will increase the motion velocity. Whereas A sin theta will try to deflect it. A sin theta will try to deflect it from its own position. That is where we are now slowly entering to circular motion. But we will go proceed slowly. At any instant, if your velocity is making some angle with the acceleration, जो उसका parallel component होता है वो उसको accelerate करेगा, मतलब जो भी है उसका motion में change करेगा, that's not our concern. And we will have perpendicular component which will be deflecting it from its own direction or initial direction. That is what we may be considering as we progress, because that is where the concept of your what do you say, this circular motion comes to the picture. Centripetal acceleration on. We will go. So basically what happens is, yes, as I was discussing, so when it comes to acceleration is in parallel to your velocity, most or more often than not it is a straight line. But if acceleration is making an angle theta, then it's not a straight line, it's a parabolic curve or a curve which is deflecting from its initial position. Now you have to understand one thing. You have to understand what is acceleration, to be precise. Acceleration is was rate of change of velocity, vf minus vi by t. Please understand that your vf may be, your vi may be along this direction, your vf may be along this direction, but your acceleration is vf minus vi, vectorially, vectorially. That means it is neither along vi nor along vf, rather it is along vf minus vi. How to write it vectorially? This is your vi, and what do you know about acceleration? vf minus vi. तो आपका vf क्या है? ये आपका vf है, वेक्टर, हाँ, माइनस vi. तो दिस इज और vi, इसका माइनस लोगे तो उल्टा. नाइस. और vf minus vi from vector, we know it's basically the resultant. So this is your minus vi, this is your vf, and where is the resultant? This is your acceleration. I'm just getting, let me just put t because I'm taking t as a scalar. So Vf minus Vi. This is the direction of acceleration. Hmm? When you think about acceleration, there are certain things that it is neither along Vi nor along Vf, rather it is the represents the direction along which we are having the rate of change of the velocity. So let's say in a circular motion, a particle is here going along this direction, which is Vi. After some time, it is here, it is Vf. That is what we have replicated it here. When this happens, your Vi changes to Vf, your acceleration is always directed towards the center. How do you know? From this, that your acceleration is Vf minus Vi, and that is basically towards the direction of center. We will come to this. Now, coming back to the factor that one component of your acceleration is a cos theta, which is parallel to velocity. Ha, ha. Sorry, I just taken t here. Yes. A cos theta is parallel to V. The component which is parallel to V will result in the increase of the velocity, or this parallel component of acceleration A cos theta will result in change in magnitude of the velocity. Hence, this will result in changing the magnitude of this velocity. And if it is changing the magnitude of the velocity, this is known as A cos theta, which will result in change in the magnitude of the velocity, which is known as, or this will give us a parallel, or this is known as tangential acceleration. This is known as tangential acceleration. Another we have, that is a sine theta. You see, a sine theta is exactly perpendicular to V. Obviously, because it is perpendicular to V, it will not be affecting the magnitude of the V, but it will be deflecting it. So your a sine theta, which is a perpendicular, is known as radial acceleration, or the acceleration which is always perpendicular to V at that instant. We are considering about that part. We are considering about that part of the acceleration which is always perpendicular to the direction of V. That is our radial acceleration, which will be contributing only in the deflection or the changing in direction. There is another acceleration which is, let's say, a cos theta, which is a parallel component, which will be contributing to the change in the magnitude. That is our tangential acceleration. Okay. So now let's enter into the discussion that we had V here, we had A here. This is a generalized thing. A cos theta is here and A sin theta is here. We realize A parallel is our tangential because this will result in change in magnitude. A perpendicular is only our radial because this will result in change in direction. Okay. Then I say, and we know that acceleration is basically given as, or instantaneous acceleration is given as del Vt by del of V vector by del of t. What does that gives you? What will that give you? That is the rate of change of the velocity vector. Rate of change of velocity vector, what will that give you? Acha, we will discuss. But before that, let me to discuss this. When we say, so far we have a parallel component or a tangential component, and we have a radial component. If I now ask you, tell me what is the magnitude of a acceleration, what do you say? A r square plus a t square. This is the magnitude. Acha. And what does that mean? That basically means mod of dv by dt. So, and this is what your a net. When it comes to net acceleration, this is given as dv by dt. Your net acceleration is given as dv by dt ka magnitude. Acha. Now if I tell you this d by dt mod of v, what does that means? That tells you the rate of change of magnitude of velocity, and that is your tangential velocity or parallel component. This is your parallel component. So your tangential velocity basically related to the rate of change of the magnitude of the velocity, dv by dt. Then there is another thing that we have discussed now here. If you take mod of e, mod of this, that gives you mod of dv by dt, which gives you the net acceleration. If you just think about the change in direction, that gives you centripetal or radial acceleration. If you think about only the change in magnitude of the velocity, that gives you tangential acceleration. Okay, now moving ahead, just okay. And just to make sure that acceleration is given as dv dt, इसको also हम लिख सकते हैं dv by dx dx by dt. So this is v dv dx. Okay, now let me to move ahead and go ahead with the discussion that motion under gravity, we have already discussed projectile motion, which is actually motion under gravity. But let me just for the sake of understanding and for the sake of to complete the syllabus, let me just discuss about motion under gravity. Motion under gravity. But before I proceed and enter into motion under gravity, I would like to discuss this problem. Just a second. Huh. So now that we have proper understanding of acceleration, that acceleration is basically, when it parallel to A, it will result in change in magnitude. But when in making an angle theta, it will not only change in not only changing the magnitude, but also it will be changing the direction. That is where we get to know about a perpendicular component and parallel component contributing to change in magnitude, which is tangential component, and perpendicular is deflecting the direction, which is known as our uh, radial part. Nice. And we know acceleration is equal to dv dt, or we can also write it as v dv dx. So now with that, before entering to motion under gravity, now let me to solve this process problem. Let's say this is v, particle is moving with 5 meter per second. Your acceleration your acceleration is 2 meter per second square. Question is, find out the distance, find out the distance traveled in 3 seconds. Let's just solve it and then we'll proceed to motion under gravity. Find out the distance traveled in 3 seconds. We have a particle which is moving with 5 meter per second, acceleration in the backward direction. Now you have to understand, or you have to tell me what is the, you have to tell me what is the distance traveled in, what is the distance traveled in 3 seconds. Yes, I have a particle which is moving in the right direction with 5 meter per second. The acceleration of the particle is towards left with 2 meter per second square. Find out the distance travel in 3 seconds. Distance travel in 3 seconds. Shubayon is saying 33 by 4. No, 33 by 4. Wait. 13. 13.2 is 6.5. Yes, Vishnu, right. 33.4 is not right. 13.2, yes. 13.2 or 13 by 2? By 2, yes. Okay, so let's discuss. So again, this is actually the same thing which you have already discussed. If you have observed it carefully, the acceleration is towards the back side. The particle is moving towards the front side. Obviously, at some point, obviously the velocity is decreasing. So ऐसे ही चलते चलते एक जगह आएगा जहां पे उसका वेलोसिटी जीरो हो जाएगा, और जहां पे उसका वेलोसिटी जीरो हो जाएगा वहां पे उस दैट इज द पॉइंट, दैट इज व्हाई इट विल बी टेकिंग अ टर्न. ठीक है, लेट्स डिस्कस. So let's understand where the velocity will be zero. Zero equals to 5 minus 10. No, not 10, sorry. 2t. Zero equals to 5 minus 2t. T equals to 5 by 2, 2.5 second. मतलब starting from t is equal to 0 where the particle was here to t is equal to 2.5, the particle will come to at rest. And what have I asked? 3 second. मतलब वो जो आगे का 0.5 सेकंड है उसमें वो क्या करेगा, वो देखते हैं. So let's discuss this. At t is equal to 0, the particle is here. And then at t is equal to 2.5, the particle will be here. Stopped. Their velocity was 5. Their velocity is 0. देन आगे का 0.5 सेकेंड के लिए पार्टिकल इस तरफ आएगा. अब कहां तक आएगा वो देखना पड़ेगा. नाउ हुएवर having the urgency or let's say tendency of utilizing s equals to ut plus half at square for to calculate this, and you have readily put t is equal to 3, that please understand this is a vector, this will give you the vector, this displacement. Whether you are utilizing v square is equal to u square plus 2fs, s is equal to ut plus half at square, or v is equal to u plus at, remember these are actually in terms of dot products. Means v equals to u plus at, लिखा इस तरीके से जाता है, s equals to ut plus half at square, v dot v equals to u dot u plus 2a dot s. लिखा इस तरीके से जाता है, लेकिन सिंप्लीफाई करने के लिए हम लोग मैग्नीट्यूड लेके कर देते हैं. बट एक्चुअली ये, और ये तब वैलिड है जब एक कांस्टेंट एक्सेलरेशन पे आप काम कर रहे हो. तो अगर मैंने आपको कांस्टेंट एक्सेलरेशन दिया है तभी आप ये यूज कर सकते हो, लेकिन अदरवाइज आपको एकदम स्क्रैच से डिराइव करना पड़ेगा ए फिजिकल टू एम ए करके, or whatever formula you want to use. Only when your acceleration is constant, then only you will be able to utilize that. And whenever you are utilizing that, please understand this gives you the vector, means displacement, velocity and all those. Displacement, velocity, acceleration, ये सब देता है. लेकिन डिस्टेंस स्पीड ये नहीं देगा, इसको आपको थोड़ा ध्यान से यूज करना पड़ेगा. क्योंकि यहाँ पे अगर आप डायरेक्टली टी इज इक्वल टू 3 पुट करोगे तो ये 6.5 नहीं आएगा, 6.25 के आसपास आएगा, जो हम कैलकुलेट करके देखेंगे. नाउ लेट मी टू डिस्कस द प्रोसेस हियर. अच्छा, how far it has moved within t is equal to 2.5. Now this is a straight line and the particle is moving constantly along a particular direction. So here I can safely use s equal to ut plus half at square. u कितना है 5, ut t मतलब 2.5, और एक्सेलरेशन या डिसिलरेशन है, फॉर दिस डिसिलरेशन है, तो हाफ 2 into 2.5 का स्क्वायर. इफ यू सॉल्व इट व्हाट विल यू गेट? 5 पच्चे 25, 5 दुगुने 10, 5 पच्चे 25, 5 दुगुने 10 तो 12, और ये आपका हो गया 2.5 का स्क्वायर कितना होता है? 2.5 का स्क्वायर होता है 6.25. तो ये आपका हो गया 6 पॉइंट, इसको करोगे 5, इसको आएगा 2, और ये आएगा 6.25 मीटर. मतलब ये आपका आया 6.25 मीटर. दैट इज व्हाट आई वाज डिस्कसिंग. नाउ अब आगे आगे का देखना है. ये जो टी, अच्छा यहाँ पे वेलोसिटी कितना है? 0. तो अब इसके लिए भी फिर से हम एस इज इक्वल टू यूटी प्लस हाफ जी टी स्क्वायर लगाएंगे जहां पे यू इज इक्वल टू 0 होगा. सो हाउ फार इट विल बी मूविंग? its initial velocity 0, but now the acceleration is working as actually acceleration, no more deceleration because it is in the direction of the acceleration. So half a टी स्क्वायर, तो 0.5 का 5 का स्क्वायर कितना थे 25, तो 0.5 का 0.25, टोटल कितना हुआ, ये कितना हुआ 0.25 मीटर। मैंने क्या पूछा था, डिस्टेंस पूछा था, तो डिस्टेंस कितना हो जाएगा 6.25 प्लस 0.25 मीन्स 6.5 मीटर, दैट इज व्हाट यू गाइस हैव डन। अच्छा, इसमें एक चीज जो ध्यान में रखना होता है कि क्या मैं इसको डायरेक्टली, अच्छा एक चीज देखो यहाँ पे डिस्प्लेसमेंट अगर मैं बोलूं, if I ask for displacement, see the displacement is between this and this point only, because displacement only